Welcome back, everyone. Today, we are diving into a full-on explainer on object-oriented programming, or OOP for short. We're going to distill this massive topic down to its absolute essence. So whether you're actively tackling computer science concepts right now, or you're just prepping for an upcoming exam, let's unpack this together and make these core ideas really stick.
Okay, let's take a quick look at our agenda. First up, we've got the shift to objects. Then, blueprints and realities. 3, the 4 pillars. 4, real-world impact. And we'll wrap it all up with your ultimate cheat sheet.
Section 1, the shift to objects. Moving from tangled code to organized reality.
You know, to really appreciate OOP, we have to look back at the massive headache early programmers were dealing with. Procedural programming was the old standard, and it was super linear. The problem? As programs got larger, this logic turned into literal spaghetti code. One tiny little tweak could break the entire system. But then, object-oriented programming swooped in. It offered this highly modular, organized solution that actually mimics real-world entities. Honestly, it was a complete game changer in how we communicate with computers.
And this shift definitely didn't happen overnight. Looking back at the 1960s, a language called Simula first introduced these foundational concepts. Then the 1970s hit, and Smalltalk really pioneered pure OOP. But the massive, unstoppable explosion, that happened in the 1990s when Java brought OOP to the absolute masses, which, of course, leads us to today, where modern OOP completely dominates the industry through powerhouse languages like Python and C++.
Section 2, Blueprints and Realities, Demystifying Basic Terminology.
All right, to actually speak the language of OOP, we've got to start with the single most fundamental concept, the class. Think of a class as basically your conceptual blueprint. It's a template or a set of instructions used to create specific, concrete objects. It holds your attributes and your methods, but, and you really want to remember this for your exams, a class is not a physical thing itself. It's literally just the idea. The contrast here makes it super clear. The class is that architectural blueprint, mapping out where the doors and windows go. But the object, that's the actual physical house built from those plans. You can't live inside a blueprint, right? You live in the object. So how exactly do we bridge that gap from blueprint to reality? Well, we use something called a constructor. It's a quick 3-step process. First, the program calls the constructor method. Second, it initializes the attributes, which is essentially just setting up the starting rules. And third, it creates the instance right there in the computer's memory. Boom, your house is built. Because without this crucial step, your code is never going to be anything more than just an idea. Section 3, the 4 pillars, the superpowers of object-oriented programming. Now we're getting to the good stuff. These 4 pillars are literally the backbone that gives OOP its structure. Pillar number 1 is encapsulation. The textbook definition says it's bundling data and methods into a single unit while restricting direct access to some of the object's components. But in plain English, it just means protecting your internal data from outside interference, so some other random part of your code doesn't accidentally ruin it. Let's ground this with a visual. Picture an actual medical capsule. That outer shell is specifically there to hide and protect the medicine inside, so it doesn't dissolve too early, right? Conceptually, in languages like Python, we use private attributes to keep our sensitive data safely locked inside its own little capsule. It completely prevents accidental changes from the outside world. Moving right along to pillar number 2, inheritance. This is a mechanism where a new class derives properties, attributes, and methods from an existing class. Honestly, you can just think of this as the ultimate cheat code for reusability. Why on earth would you sit there writing the exact same lines of code over and over again when you can just inherit them from a relationship you've already established? Think about it like this. A brand new smartphone automatically inherits basic calling abilities from the original telephone. You definitely don't have to reinvent the concept of a phone call just to build an iPhone. And in the code, Python child classes automatically inherit parent class methods in the exact same way. It saves developers a massive amount of time. Okay, pillar 3 is polymorphism. I know, it sounds like some heavy academic jargon, but look at what it actually means. It's simply the ability of different objects to respond to the exact same method call, each in their own unique way. Once you visualize it, it's actually incredibly intuitive. See, if I issue a single speak command, a dog will bark, a cat will meow, and a cow will moo. That is polymorphism in a nutshell. One simple command, multiple unique outcomes, depending entirely on which object is receiving it.
In your code, you can easily override methods so they behave perfectly for the specific object you're dealing with. And finally, our fourth pillar, abstraction. This is the practice of hiding the complex, messy implementation details and exposing only the essential features to the user. Basically, it's all about keeping the user interface clean and simple by hiding the absolute chaos that might be happening behind the scenes. The classic way to think about this is driving a car. You don't need to be a master mechanic to drive to the grocery store, right? You just need to know how to use the steering wheel and the pedals. You don't need to understand the physics of engine combustion. Abstraction ensures that developers don't need to read every single underlying line of complex logic just to use a class successfully.
Section 4. Real-world impact, where OOP shines and where it struggles.
Okay, so the theory is great, but what does this look like in the real world? The advantages are huge. We're talking massive scalability, superb reusability, modularity, and really tight security thanks to encapsulation. But we have to acknowledge the disadvantages too. There's a pretty steep learning curve, the code can sometimes execute a bit slower, and honestly, it is way too easy to over-engineer things. I mean, you really don't need a massive multi-tiered object hierarchy just to print "Hello World" on a screen. But despite those drawbacks, understanding OOP is absolutely essential. Just look at the heavy hitters: Python, Java, C++, Ruby, C#, PHP. By mastering the basic concepts we've talked about today, you're not just memorizing one trick. You're actually gaining the master key to almost every major modern programming language used in the industry right now. Section 5, your ultimate cheat sheet. Rapid-fire exam and interview prep. All right, let's say you're stepping into a major exam or a job interview tomorrow, and they hit you with this classic question. What is the exact relationship between a class and an object? Take a second. Do you remember our analogy from earlier? A class is the conceptual blueprint, or template. An object is the physical instance created in memory from that blueprint. Boom, you nail that, and you've just proven you truly understand the beating heart of object-oriented programming. Before we wrap up this explainer, I want to leave you with a thought. As software development continues to rapidly evolve, especially with AI integration and totally new programming paradigms hitting the scene, do you think these 4 pillars of OOP will stay the dominant blueprint for building our digital world? It's definitely a fascinating question to ponder. Thank you so much for hanging out with me for this explainer. Keep learning, keep organizing that code, and I will catch you